All right, we're going to start this lesson with a warm-up. So I would like you to pause the video, try these two questions, and when you're ready, you can go ahead and hit play again. Okay, now that you've had a chance to try the warm-up, I'm just going to go to the next slide where I already have all my answers worked out for you. And you can pause the video here to kind of go through and check all of your work. Today's goal is to work with radicals a little bit more and kind of focus on how to add and subtract radicals. So in the last lesson, you learned the multiplication and division properties. Now, what do you do with adding and subtracting? We basically just noted in the last lesson that there wasn't much that we could do with addition and subtraction. So I'm going to show you what you can do with those now. And I'm going to first remind you of something that you would have done in Algebra 1. So that is combining like terms. And I'm reminding you of this because combining or adding and subtracting radicals is a whole lot like combining like terms. Remember that when you combine like terms, the process is looking for things that have the same variable and adding their coefficients. Their coefficients are the numbers in front. So if I wanted to add all the x's together, I would say 4x and negative 5x are like terms. I would add 4 plus negative 5 to combine those like terms, which gives negative 1. The procedure for adding and subtracting radicals will be much like this. Okay, so like I said, if you're going to be adding like terms together, you're going to be looking for the coefficients attached to each of those terms, and you're going to be adding the coefficients together. Well, with radicals, it just looks a little bit different. So when I look at these two radicals down here, I would say that they are like radicals, kind of like terms, because they both have a radical 2. They both have a square root of 2. That makes them alike. Now you're going to take the numbers in front, these are called coefficients, and you would add those numbers together, which gives you 4, and you would bring down your like radical, and that would give your whole answer. So 4 radical 2 would be what you would get if you added those two radicals together. Couple of vocabulary things. So if I have 2 cube root of 18, 3 is actually called the index of the radical, makes it a cube root. The number inside is called the radicand, and the number in front is called the coefficient, okay? So in order for two radicals to be like radicals, they have to have the same index, and they have to have the same radicand. Let's look at an example. So I want you to add like radicals down here. Well, they all have a 2, well, these three things have a 2 on the inside, but only 2 of them have the same index. This one and this one have the same index. So only these 2 are actually like radicals, and I'm allowed to then add their coefficients. So 5 plus negative 4 would give me 1 radical 2 if I combined those two. My other two terms remaining both have the same index, but they don't have the same radicand. So they cannot be combined because they are not like radicals. So if my question said to simplify, I would not be able to simplify any further. So I would just need to bring down those two terms that are not like radicals. And that would be all you could do here. So here's a written down process for, I know some of you really like steps. So if you're someone who likes steps, here you go. How do you add or subtract radicals? Your first step is you're going to simplify the radicals that you have before you do any adding or subtracting. Simplify the radicals. Step 2 is look for like radicals. Remember, they have to have the same index and radicand. And then you're going to combine the radicals by adding or subtracting their coefficients. All right, for this first example, again, I'm going to go through my 3-step process. And the first thing it says to do is to simplify each radical. So I need to kind of break it down the way that I showed you in the last lesson in 2.1 and rewrite it. So this one would be 2 with a 2 left on the inside. So 2 radical 2. And I'm also going to break down the square root of 98. I can take out a 7, and I've got a 2 left behind. So I have a 7 radical 2 for that one. Okay, that's step 1. Step 2 is look for like radicals. I have both square roots, and they both have the same inside number, so I can add them together. And I'm going to add their coefficients in order to do that. So 2 plus 7 would be 9. And you just leave the radical untouched. So 9 radical 2 is the answer. Let's try another one. So step 1 is you're going to break this down and simplify all the way down first. This is a cube root, remember, so I have to have 3 of the same thing in order to be able to remove it from the radical. So this would be 3 on the outside and still a 3 on the inside. And then for 24, I can take out, looks like a 2, because I have 3 2s. This is minus. So it would be 2 on the outside, but I still don't have a match for the 3, so that goes back. Step 2 is look for like radicals. I do have like radicals again because I have 2 cube roots, both with 3's on the inside. So I'm allowed to subtract their coefficients, and their coefficients are 3 and 2, so 3 minus 2 gives me just 1 cube root of 3, which I think I'm just going to not write the 1 since it's just a value of 1. I can call it cube root of 3. This one's tough. Okay, so C, this is difficult because we have fractions, and the first thing you have to do is you have to simplify. You have to simplify each radical. Well, in order to do that, I'm going to have to do, whoops, the square root. I'm going to apply the division property right now. That's what I'm doing, and that's just separating the square root so that it's on the top and the bottom. And then I have to rationalize each of these because you aren't allowed to have a radical in the denominator, remember. We learned that last time. So I'm going to kind of work on both of these at the same time. And remember, to get rid of that radical in the denominator, you're just multiplying both the top and the bottom by the denominator. Okay, so I'm kind of doing 2 problems at the same time right now. I apologize. I know this is messy. 32 times 3, that's 96 over radical 9. And then over here we would have 6 over radical 9. And then what's square root of 9? Isn't that 3? So this would just be a 3 on the bottom. And a 3 on the bottom. Okay, this is looking better. We still, though, have not simplified inside the radical. So like 96, is it possible for that to break down? 96 is 2 times what? Oh my gosh, I'm having a brain fart here. 48? Yeah, 2 times 48. 48 is 6 times 8. 6 is 3 times 2. 4 times 2, 2 times, okay, there we go. So this is a square root, so I'm looking for 2 of the same thing. There's one group, there's another group, and then I think I have extras. So this is going to be 2 2's removed, and a 2 and a 3 still left, which would equal 4 radical 6. So square root of 96 can be rewritten as 4 radical 6. Radical 6 does not simplify. Now we're finally to the part where we can do something. So on the top, do you see how these are both like radicals? This one over here doesn't have a coefficient, but you could put a 1 there. And because we do have a common denominator of 3, we are allowed to add the tops together so long as they are like radicals, which they are. So add the coefficients, and you get 5 radical 6 over 3. That's a pretty tough question. There's a couple other ones you might come across. This is not exactly just addition problems, but a little bit like of an application, a little extra something. So this one, obviously you can tell this is a distributing question. So you're gonna go ahead and distribute. So your first step is to do radical 6 times radical 2, and then radical 6 times radical 3. Remember, your multiplication properties do allow you to multiply these two inside numbers together to just call it radical 12. And then same thing over here would be radical 18. Now it becomes an addition problem. So now you're going to go through the normal procedure of simplifying, looking for like radicals, and then adding those like radicals together. So I'm going to simplify each of these. In radical 12, that's going to reduce to 2 radical 3. And then this one is going to reduce to 3 radical 2. And that's step 1 of the adding procedure. From here, you're going to look for like radicals, which you actually do not have any. Radical 3 is not the same as radical 2 because they have different radicands. They cannot be added together because they're not like radicals. So this would be as far as you can go. I think this is my last example here. Nope, I've got one more after that. Almost done. The next example is a division question. You're dividing the entire numerator by radical 3, which would probably be easier to see if you broke it up like this. Let's look at just one group at a time. I actually think in this particular question, it's probably going to be faster to use the division property. Like back here, we had to rationalize and do all that mess. But here, if you look, 21 and 3, those are divisible by one another. 15 and 3, same thing. So what I can do is use the division property, which just allows me to put the two things that are being divided into one radical. That way I can actually just divide them. So I'm going to do that, and then I'm going to say 21 divided by 3 is 7, and 15 divided by 3 is 5. So that takes me to here. And then I would simplify, except I can't here, so skip that step. Look for like radicals. These are not like radicals because they have different inside numbers, so you would be done. Challenge problem. So the goal is to add and subtract all these things. Again, you cannot do so unless you have like radicals. And a lot of times you can't see like radicals unless you simplify first. So let's get to work. We have to simplify all of these radicals, okay? So we're going to have the 12, we broke that down. X to the 5th is 5 x's, and I'm doing a square root. So let's see. I can take out a 2, and then I can take out one group of x's, 2 groups of x's. So I would have 2 times x, and then square root of 3x would be the two things that are left on the inside. If I want to keep going, I could simplify that to 2x squared. All right, let's go to here. 3 doesn't break down because it's already a prime number. So I just need to figure out x to the 3rd. I think I can take an x out, can't I? And I already have an x out here. So there would be 2 of them now. And there's still an x and a 3 left on the inside. Which, if I want to multiply the x's, that would be x squared radical 3x. And then this last thing, 3 doesn't break down, and neither does a single x. So this I would just drop down. So we are done with step 1. Step 1 is where you simplify each radical. Now step 2, look for like radicals. Well, they all appear to be square roots, which means they have the same index. They all have the 3x on the inside, which means they have the same radicand. So you are allowed to combine the radicals. So you need to do 2x squared minus x squared plus 5x squared. So 2x squared minus x squared would be 1x squared, plus 5x squared would be 6x squared. And remember, when you add, the radical will not change. It will stay radical 3x. Okay, that's it for the lesson. Remember that you are being graded simply on the note-taking part. So you just have to take notes over this video and submit that on Classroom. And you also have a Delta Math assignment to accompany this lesson.